Welcome back to Wildcat Academy. Today we'll be learning about factoring polynomials, in particular the method of difference of squares. But before we get into factoring, I want to review the idea of conjugates. Conjugates are when we have a binomial, such as a plus b, and then we have changed the sign from plus to minus, or vice versa. But in particular, the first term is exactly the same, and the second term is exactly the same, but the middle sign is positive in one binomial and negative in the other. So you can see when we FOIL this out or distribute the a and the b into the second parenthesis, we'll get a squared minus ab plus ab minus b squared. And then the middle terms are going to cancel out. They become identical because of this change in sign. That occurs because of one term is positive and the second term is negative. So these will cancel out or sum to 0, and then we are left with a squared minus b squared. And this is where we have what we call the difference of squares. Because we have two terms, a squared and b squared, and we are there's a minus between them. We are subtracting those. So that is going to be fairly easy for us to recognize because we're going to have a perfect square term here in a and a perfect square term here in b squared. So just to review a little bit more, I want to go ahead and review our perfect square numbers. 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144, and 169. Most of the ones that we deal with on a regular basis are created from the first 13 natural numbers squared. There's also a 1 here, but we typically just understood that that is there. It doesn't make any problems any more difficult. So, but we do need to recognize it. So let's go ahead and jump into example 1. So we have x squared minus 25. So we're going to identify that this first term is a squared and the second term is b squared. And you can go back to our pattern here, and it is going to factor from a squared minus b squared into a plus b and a minus b. And these two binomials, you can switch these out because multiplication is commutative, so we can make this a minus b and a plus b. The order will not matter, it's personal preference. So the first thing we want to do is identify that x squared is our first term and 25 is our second term. So we'll just mentally take the square root of those, or ask ourselves what times itself gives us x squared, and that will be x. That will be our first term, or our a value. And then our second term, b, will be the square root of 25. So we'll have a 5 and a 5. And then we could just arbitrarily assign one positive and one negative. And it's as simple as that. The biggest difficulty with these is going to be recognizing when to use difference of squares. So a couple of tips. When are we going to use difference of squares? Tip number 1 is there will always be two terms. We were not going to use difference of squares on 3 terms or 4 terms. We're only going to use it when we have 2 terms. So this is one of our 2-term methods to factor. The other tip here is going to be our degree of our variables will be even. The degree of our variables will be even. So if we have odd degree variables, such as like a cubed minus 8, that you'll see in a later video, this would be the difference of cubes, because you can see the degree of our variable is not even. So these 2 tips will help you recognize when to use difference of squares. So let's go ahead and jump into example 2, a little bit more complicated. We have a leading coefficient on our x squared term that we're going to have to deal with. Again, we're going to recognize a squared and b squared. And once you recognize those 2 terms, 4 is a perfect square. We have our degree of our variable is even. and the second term is also already a perfect square. So we're going to take the square root of 4, or ask ourselves what times itself gives us 4. That's going to be 2. And the square root of x squared is x. And we'll do a very similar process with 100. We'll take the square root of 100, which is 10. And just like I said, we can arbitrarily assign one positive and one negative. In this case, we change these. So the first binomial is now negative and the second one is positive. That is interchangeable because, again, multiplication is commutative. So if you don't remember what multiplication being commutative is, that is where 2 times 3 is equal to 3 times 2. All right, so 2 more examples here. Again, we've changed our leading coefficient from 1 to, again, a perfect square. In this case, it's 9. We have our second term, which is also already a perfect square, which is 36. So we have our a squared and our b squared term. We're identifying that minus sign in between. So we're going to take the square root of 9, which is going to be 3, the square root of x squared, which is x. So both of these terms will be identical, 3x and 3x. And we're going to take the square root of 36, which is 6 and 6. And then one will be positive and one will be negative. And go ahead and jumping into example 4 again. We will take the, identify the first term and the second term. 25x squared is going to be our a squared. We're just going to take the square root of that term. So mentally, again, I'm going to, on example 4, it's going to be our last example. So I'm going to draw that out just a little bit more. So mentally, what am I thinking? I'm thinking that 25x squared, what is the square root of that? So I'm going to simplify this, this radical in my head mentally or over to the side, and that's going to be 5x. And then I'm also going to simplify what is the square root of 144. That is going to be 12. So you can see the first terms, a will be 5x and 5x, and the second terms, b, will be 12 and 12, and then one will be positive and one will be negative. All right. Well, if you enjoyed this video, please hit the like button below, and if you haven't already, go ahead and subscribe to the channel and look out for more great videos from Wildcat Academy.